is where we put it all together. So I apologize for problem number 2. I did it correctly, but I made one small error when I was speaking, and I thought about it, and I was like, could I sleep at night knowing I made one significant error in a video? And I would rather redo the video properly and teach it thoroughly than give you like some half effort video. So anyway, the directions state find. Let me. Sorry, I was on a separate piece of paper. Find the exact value of each of the remaining trig functions of theta. So find the exact angle is basically what the directions say. So for problem number 1, sine of unknown angle, so sine of theta is equal to 5/13. Also, theta is in quadrant 2. So what does that tell me about the angle? Quadrant 2 is any angle between 90 degrees and 180 degrees. So what this means is find me the quadrant 2 angle that has a sine ratio of 5/13. So I'm a visual person. I'm not one of those people who can do a math problem in 3 seconds, or just I'm not quick. I'm very thorough, and I think that's what makes me a teacher. Is I like to draw a picture. So step 1, I would draw a picture where the angle is in quadrant 2. And basically the goal is, it's not drawn to scale, but the idea is we're trying to find this reference angle, because remember that a reference angle should have the exact same cosine and sine, but depending on which quadrant you're in, one of them should be negative or positive or whatever. But since we're in quadrant 2, can we agree that the sine should also be positive? Yeah. So we're trying to meet up with this terminal point and have the exact same sine ratio. But remember, my calculator will only recognize angles up to 0 to 90 degrees if I try to solve for the inverse sine of 5/13. Does that make sense? So anyway, let's take a look at this picture. It's a quadrant 2 angle, and the reference angle is meeting the x-axis. So I'm going to draw a right triangle where the coterminal point meets the x-axis. So if I were to take this dot and just bring it down, let me get my red just to give it an idea. So what I would do is I'm just going to bring this down like a line. Let me just draw a little dotted line right there, or just a solid line right there. So I want to create a right triangle that looks like this. Sorry about that. So we've got a 90-degree angle here and an angle theta. And according to our information, we've got a sine ratio. Now remember, sine is the ratio's opposite over hypotenuse. So since the sine ratio is 5/13, that means that the numerator is the opposite and the denominator is the hypotenuse. So if the sine ratio is 5/13, that tells me that the opposite side is 5 and that the hypotenuse is 13 compared to angle theta. So theta's opposite side should be 5 and the hypotenuse should be 13. Therefore, now that I've got the triangle that makes more sense to me, I'm going to do sine of theta is equal to 5/13. And now I'm going to solve for angle theta. How do you propose I solve for angle theta? Well, I've got a sine ratio, and the only way I can cancel out a sine ratio is if I do the inverse trig function, sine inverse on both sides. So now, the sine inverse of sine of theta is equal to the sine inverse of 5/13. The sine inverse cancels out with sine, leaving me with angle theta. and it's going to be a decimal, so I'm going to put the squiggles, so approximately. Let's round to the nearest 3 decimal places. So I want to calculate the sine inverse of 5/13. And I'm going to round to the nearest 3 decimal places. So my sine inverse is 22.619, and that 4th decimal place is an 8, so I'm going to round this up to 22.620 degrees. Yeah, 22.620 degrees. But remember, that's my reference angle. I'm just making a little note to myself. I want to solve for the quadrant 2 angle. So I want to solve for the quadrant 2 angle. Well, let's look at the diagram. How do I solve for this black angle if I know the reference angle? Well, can we agree that black angle plus red angle is 180? So the black angle should be 180 minus the red angle. So 180 minus the reference angle is, in fact, the black angle. So the quadrant 2 angle, is equal to 180 degrees minus 22.620 degrees. And if I do put that in the calculator, my quadrant 2 angle is approximately, my quadrant 2 angle is approximately 157.38 degrees. Now, before you go out and say, hey, you're spitting out nonsense, well, you can check your work. Remember that the angle we want, the angle that we solve for is 157.38. And according to the diagram, our sine is 5/13, but the angle is in quadrant 2. So why don't I actually plug in 5/13 in the calculator? That's my sine ratio as a decimal, so 0.3846, blah, 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 blah. And then I'm going to do the sine of the angle that we solve for. Sine of 157.38, and see if it lines up with the sine ratio being 0.384615. Pretty darn close. Look at that. They practically match up. Okay, the more decimal places you use, the more accurate your solution is going to be. I figured 3 decimal places is enough, even though it's 380. But yeah, that's how you do it. So let's do problem number 2. I'm going to lead you through this as well. Okay, so problem number 2. The cosine of angle theta is -8/17, and the angle is in quadrant 3. So I did this problem. Already, and I just wanted to show you that I kind of misspoke, and I'd rather do this thoroughly. So what does this mean? So the cosine is -8/17. Okay, so that tells me the adjacent over the hypotenuse. And because theta is in quadrant 3, that tells me that the angle is between 180 and 270. Okay, so I like to put my brain on paper and think. So I decided to draw a quadrant 3 angle, and because we're trying to solve for the reference angle, it's going to be where it matches up with the terminal point and the x-axis. So I'm going to make a right triangle out of that by making my cosine, my adjacent side of this triangle is 8, and my hypotenuse of this triangle is 17. Even though in the problem it says -8/17, let's think about something more concrete. A triangle has positive units for its side length. So I'm going to make a triangle where it's 8/17 for the cosine ratio. So now that we know that the cosine of angle theta is 8/17, how do we solve for angle theta? Well, the only way to get rid of that cosine function is to do an inverse trig function. What inverse trig function is going to cancel out cosine? We need to apply inverse cosine on both sides. So that means that the inverse cosine cancels out with cosine, and so we basically know that angle theta is the inverse cosine of 8/17. So then I pull out my calculator, and I round to the nearest 3 decimal places, and my reference angle in that triangle is about 61.928 degrees. So this theta is 61.928 degrees. So what do you think this entire what do you think this entire angle is? If this is 61.928 degrees. Right, I need to add 180 to this reference angle to get the entire quadrant 3 angle. So my quadrant 3 angle is 180 plus 61.928 degrees, or approximately 241.928 degrees. So let's compare that with the calculator. So the trig function that we were given is the cosine is equal to negative 8/17. So I'm going to plug in negative 8/17, whatever that may be, negative 0.47058, blah, 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 blah. And I'm going to compare that with the cosine of the angle that we solve for. Cosine of 241.928. Hopefully they're identical practically. Oh, look at that. Oh, that's pretty. Oh, I'm so proud. I'm so proud. So I like to show my work for these problems because my brain does not think, okay, what's the formula again? I'm a multisensory learner. So if you can do this in fewer steps, I mean, I'm not telling you to work less than you have. I'm not telling you to work harder. I'm not telling you to work less. I'm saying work with what benefits your intelligence. So that's just how I do it. I like visuals and math at the same time. So let's take a look at problem number 3. So I didn't, this is where I left off in the video last time, so let's do this one together. Okay, so solve for the angle that has a sine ratio of negative 4/5, okay? But note that the angle is in quadrant 4. So let's draw a picture. So I'm going to start here. And remember, I'm in quadrant 4. So this is my terminal point. I want to solve for this angle theta. Now, before I do that, I'd like to make a triangle. Okay, so what I can do is I draw this triangle in that bottom right, okay, and fill in the appropriate information. So they gave us a sine ratio. Let's just make it positive for now. We know that the sine in quadrant 4 has to be negative since the y value is below the x-axis. So if I were to draw a sine ratio with if I were to draw a triangle with this appropriate sine ratio, remember we're solving for this theta, and according to the sine ratio, it's opposite over hypotenuse. So that would mean that the opposite side is 4, and the hypotenuse is 5. So this is 4, and this is 5. So if I look at my sine of theta, that is 4/5. How do I undo the sine ratio? Sorry about that. How do I undo the sine ratio if I want to solve for angle theta? I'm gonna apply inverse sine on both sides of the equation. So now I've got inverse sine of 4/5 on the right side. Inverse sine and sine cancel out. And I'm going to get, if I plug in inverse sine of theta of 4/5 into my calculator, it's always going to present as an angle between 0 and 90 degrees. So that would be 53.130, or if you like 53.13, that's fine as well. But I like to round to the nearest 3 decimal places just because. So this is 53.130 degrees. But remember that this is the angle theta reference angle. I want to solve for the black angle, the one that goes all the way around. So that tells me that this is the quadrant 4 angle. So how do I solve for the black angle if this is 53.13 degrees? I've got to subtract it from 360. So Q4 angle is approximately, let's plug it in the calculator, 360 minus 53.13. So that's approximately 306.87 degrees. And if you don't believe me, you can check your work by comparing the decimal of -4/5. I believe that's -0.8. So -0.8 is the decimal form. And I'm going to compare that to the sine of the quadrant 4 angle. So let's compare sine of 306.87 with the -4/5. So close to -0.8, it's practically the same value. The more decimal places you use, the more accurate your solution will be. This takes a lot of practice, so we will do multiple videos with this exact topic. Who knows, we might cover 3 problems, 4 problems, but we're going to do some critical thinking. Have a great day.